Okay, guys, today we're going to look at the urinary system. I hope things are okay with all of you at home. Remember, if you're having issues with turning any work in, anything that's kind of disrupting your ability to carry out work, please, please, please let me know. We can find ways around it. Okay, we're looking at the urinary system. This is chapter 17. Again, like I keep saying when I do these videos, I'm going to go faster than I ever would in class. So please pause, write the notes down. If you want to look something up, you have that pause button, so please use it. Okay, so primary function of the urinary system is to filter out waste from the blood and remove it from the body. So as your cells are working to do things, produce things, make proteins, make energy, rebuild. All of these functions that are going on inside of your cells, they're going to produce waste. That waste ends up in the bloodstream and it needs to be taken out of the bloodstream or filtered and then removed. Because if it continued to build up, it would be toxic and eventually life would not be sustainable. Okay, so we have to get rid of all those waste products, and the kidneys and the urinary system is what does that. Okay, so the waste that we produce from the blood is urine. Okay, so your urine, when you go pee, that is a product of what was in your blood. Okay, it's not to do with what you have eaten, but it's the waste products in your blood. Okay, so what that urine is made up of is a whole bunch of water, but also a lot of cellular waste that's really rich in nitrogen. Okay, so you see things like in there like ammonium, which is NH3. Um, and like I said, these waste products, they are toxic to the body if they are not removed. Okay, so I just alluded to that kidneys are the primary organ that are responsible for this. Um, Basically, the kidneys are the filter. So your blood runs through through your kidneys, okay, and that's constantly happening. And the kidneys have a way of removing waste products, which we'll get to in a second. And then if you can see in that diagram here, we have the kidneys and then we have a tube that's coming out of the middle of them down into this reservoir at the bottom. Okay, that reservoir is your bladder. So the blood goes into the kidneys and then it comes into this tube, into the bladder, and then gets peed out at the bottom. Okay, we have two kidneys, one, two, and they are located at the lower back towards the back of the body, so towards the posterior of the body. They don't sit like underneath your abdominals; they are right at the back. Now we have two, just in case one doesn't work anymore. So kidneys are something that can be donated by a live donor. And some people do that. They end up donating a kidney to a loved one to keep them alive, and they're able to function with one kidney. Okay, so this is how the kidney does its magic. It basically has a million of these little units inside it. Okay, it's called a nephron unit. So usually when you see that word neph in bio, it's referring to kidneys. So we have a whole bunch of these, and we're going to look on the next page what each of the elements are. And because this is kind of a little complicated and probably new to a lot of you, I'm going to flip back and forth. But I want you to kind of see a couple of things here. And you should have drawn this already. So if you have your drawing, go ahead and get it out so that you can look at it while I'm talking about it. But we have blood going in, right? So we have red blood going in, and it goes into this little capsule of blood, which is a whole bunch of blood vessels all together in a small place called a glomerulus. And it is wrapped around by this yellow tube. Okay, this yellow tube is called the Bowman's capsule. And then that tube goes down here, loops back up, and then out. And ultimately this ends in the bladder. So basically, what is happening here is the blood gets forced inside this capsule, and a lot of the blood gets pushed the um, into the tubule, okay, into Bowman's capsule. So waters, sugars, proteins, waste, all of it gets pushed into the tube, and then the tube runs down, up, and out. Now you will notice that the tube, as it goes down and back up and out, it is wrapped in more blood vessels. Okay, so the blood goes in, and then the blood then wraps back around the tube before it leaves. The whole point of this is lots of stuff gets forced out into the tube, and then it's reabsorbed back into the bloodstream and this in the loop at the bottom. So everything gets, not everything, but a lot gets pushed out, and then some of it is reabsorbed. And this is how we control how much water and sugar and protein we choose to get rid of. It's basically we push everything out and then we take back what we need. Okay, so let's go and have a look at the definitions. The Bowman's capsule and glomerulus, which I just talked about, at this point, water, waste molecules, and a bunch of other stuff gets forced out of the blood into Bowman's capsule and flows down into the tubule. Okay, so it gets pushed out. That leaves the blood with a lot less in it. The tubule then drops down and back up. If I flip back to it, there we see the tubule going down and back up. Anything that we need to keep hold of. So if it is a really hot day, we're going to pull lots of water back in. Okay. If our body recognizes we have a lot of fluid in our system because we've been drinking a lot, it's going to leave a lot of that water still in the tubule. But depending on the situation of our body, we're going to reabsorb everything we need. That's why when you drink a lot, you end up peeing a lot out, right? Because your body recognizes we don't need all of this. We don't need to reabsorb it. Whereas if you are super dehydrated, you don't pee very much because all of that stuff that's ending up in the bladder gets pulled back into the bloodstream because you need it. Okay, so that's the tubule. That's where the reabsorption happens. The last part is the going towards the ureter. So all of the concentrated waste that we don't need anymore, some water, some waste products, some sugar, some proteins, or anything that we don't reabsorb ends up going down a tube called the ureter. If I go back to look at this, going down here, this ends up in the ureter. So a million of these little mini tubules end up back going into a large tube where everything flows. Okay. So let's just talk quickly about, or go back over some of the things I just mentioned. So the whole point of that pushing out and then reabsorbing is to preserve a balance, okay, preserve homeostasis in relation to a whole bunch of stuff, water, sugar, protein, acidity as well. So if we're going to read this, body preserves balance in the amount of water, salts, acidity, and other materials. If there's too much excreted in the urine, that means it's not being reabsorbed. Okay, so if we're peeing out a lot of sugar, that means that I have loads of sugar in the bloodstream and I don't need to hold on to it. So we can get rid of sugar in the urine. And this is how diabetes was initially diagnosed. And when I say initially, this was like in Roman times, a long time ago. So diabetes has been around. Basically, somebody who is diabetic often is going to have uncontrolled sugar, so they're going to have really high sugar levels in their blood. They can also have low, but in this case, they could be really high. If they have lots of sugar, then it all gets pushed into the tubule, and the blood doesn't need to reabsorb it because there's already tons there. So you get this sugar being excreted in the urine. And that's what diabetes actually means. Diabetes mellitus is Latin for sweet urine. And that was originally how it was diagnosed, was if somebody had sweet urine that was disgustingly tasted back in Roman times. Okay. So after it leaves the kidney, that nephron unit, all of those tubules they flow into the ureter. Okay, and we have some arrows at the top to show the order of exit from the kidneys to the outside world. So it goes from the kidneys into the ureter. The ureter then goes into the bladder. The bladder then has a tube at the bottom called the urethra, and the urethra is the exit of urine out of our body. Okay, so definitions: ureter is a tube that connects the kidneys to the bladder. Um, your kidneys are constantly filtering blood, so that means there's constantly waste products and urine being produced. So urine moves down the ureter into your bladder every 15 seconds in a normal environment. Okay, so it's constantly a little slow drip, 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 is filling your bladder up slowly. Now, the bladder is a hollow organ. It's flexible, which means that when it gets full, it can flex and get bigger, so that you can hold it instead of it just hitting that top mark and there's no more room and it comes flooding out. So it's flexible to give you some control about when you go pee. And it's a reservoir, because if there was no reservoir, that would mean that every 15 seconds you would be peeing. Just a little bit every 15 seconds. That would not be very comfortable for any of us. So it's basically a reservoir to let it build up, and then you can get rid of it all at once at the appropriate time if we had enough restrooms on campus. So the exit from the bladder is controlled by a sphincter. Basically, that is a ring of muscle that can contract to not allow anything to go through, or it can relax to allow the urine to come out. That's why when you go pee, you usually want to think about relaxing to allow it to flow. Okay, because you want to relax the sphincter in the bladder to allow it to flow out of the urethra. Okay, um, the last element here is the urethra. That's the tube that connects the bladder to the outside of the body. Now, I do have a couple of EMT stories, but I'm not really willing to put them up on YouTube for everybody to hear because, these are talking about real people. I don't really want to put it out there, even though I would never share their name. Perhaps at some point when you are, if you come back into my junior class, we can talk about those stories at a later date. Okay, so how do we care for our urinary system? The first thing is hydration, right? So this is a system that is removing water from our system overall. So for it to continue to work constantly, we should be hydrated. Okay, that helps us move the other waste products out. So we want to drink an adequate amount of water. Adequate means just enough. Okay, so 8 times 8, 64 ounces a day. We should, I think, be drinking more than that, being in a warm environment. So, we want to be upwards of 80 to 100. Okay, good nutrition. Just everything in our body functions based on what we consume. Okay, so we want to consume good things to allow our system to function. Really important, the next one is personal hygiene and the exit of the system. Okay, so you want to be cleaning the exit because where urine comes out is also where bacteria and viruses can go in. And we want to avoid things like a urinary tract infection because what that is where you get a pathogen going into the urinary tract, the urethra, and causes inflammation, infection, which can be painful and not good for you. Now, UTIs or urinary tract infections are more common in females than males, and it's to do with the anatomy, right? So if you think about a female, the exit of the pee, the urethra, is much closer to the exit of fecal matter from the digestive tract. So sometimes you can get cross-contamination from one to the other. Girls will probably know this, and I know this because I am a father of girls. Whenever I, changing diapers on my newborn, well, she's not newborn anymore, she's 3. You always wipe front to back because you don't want to wipe stuff at the back towards the front because that can lead to an infection, and we want to avoid that. For guys, they are separated. Obviously, if you think about what the male anatomy looks like, the urethra's exit is much further away from the exit of the colon in males. Okay, so we get less contamination. So UTI, they still happen, but they're much less common in a male than a female. Okay, so infections, what we just talked about. This is kind of the major problem with the urinary system. So basically, an infection is where we get bacteria, virus, even a parasite invading and then multiplying inside of a body tissue. Okay, so with an infection, we typically see things like inflammation, pain, temperature. Um, those are signs of infection. Okay, so cystitis is a bacterial infection. So the pathogen is a bacteria of the bladder, and if left untreated, it can travel up the ureter to the kidneys. If it gets into the kidneys, it becomes really, really quite dangerous. Next up is urethritis. Now, hopefully, it makes sense to you that urethra and itis, put those words together, we get urethritis. So we have an inflammation, infection of the urethra. Okay, and again, this one is bacterial. And this is why UTIs are linked to the proximity to the colon, because in the digestive tract, we mentioned there's a lot of bacteria, millions and millions of bacteria live inside of your intestines. And they're fine there. But when they get out and go to other places, that's when they cause problems. Okay, so that's why. Symptoms, the primary symptoms for a UTI is a burning sensation during peeing. Peeing should not be painful. If you have more frequent pee than normal, that can be a symptom as well. And then the fever, because it's an infection, part of the body's response is to get that elevated temperature. And then the question here is, why is this more common in men than in women than men? And I explained that to you. So it's the proximity between the urethra and the colon. Okay. We have some problems associated with the kidneys, nephritis. Hopefully you guys can pick up on that. That's an infection of the nephron unit, right? So it's going to be an infection in the kidneys. And then kidney stones. So in a similar way to gallstones, where the bile crystallizes and forms little pebbles, that can also occur in the kidneys. So we can get salts in the urine. So this is why if you have a poor diet with a lot of salts and minerals in there, they can crystallize into solid stone. So typically this will happen in the ureter into the bladder. You get the crystallization inside of the bladder, and you get these pebbles. Or some of them, honestly, are not pebbles. They're more like little jagged rocks because it's crystallized. Crystals usually have that more jagged appearance. And basically, the way you get rid of these is you have to pee them out. You have to pass them. And this can be incredibly painful. So, you guys can imagine what that's like. Especially this is worse for the male because the male urethra is narrower than the female one, has a narrower exit. Okay, so if you had to pass a stone through that exit, it would not be very pleasant. Now, if you have a larger stone that won't even fit into the urethra and can't get out of the bladder, typically what happens is you go to your doctor because you have this pain in your abdomen, and they will use sound waves to break those stones up into smaller pieces, but then they still have to be passed. So, basically what that is medically, not just attaching like a speaker to your stomach where the bladder is and pushing these sound waves in to break them up so that they can be passed. Still uncomfortable though. Okay, now ultimately what can happen is kidney failure. So this can occur in a couple of different ways. Sometimes we can have acute kidney failure, which means it's happening quickly over something else that's going on in the body. Or we can have chronic kidney failure, which is more common when people have had poor diets for a long period of time, high blood pressure. And basically, what kidney failure is what it sounds like. It's like the kidney loses its ability to function and filter bloods. So it becomes impossible to get rid of that waste. Now, if this occurs, there are two options. Okay, so there's hemodialysis and a kidney transplant. So I'm going to look at the transplant first because that's probably easier for you guys to think about. Basically, that's taking a kidney from either a live or a deceased donor and placing it into the body so that it can kind of take over. Now, that's challenging. It's challenging to find healthy donors, and then it's challenging to find organs that will just match up and mesh in somebody else's body. So not very many kidney transplants happen, and they are not that successful. Okay, the other option, which is far more common, is hemodialysis, which is basically hooking the person up to a machine, taking blood out of the person, running it through the machine, and putting the blood back in. So your kidney is about, the size of a fist, and it works really efficiently at doing what it's supposed to do. The hemodialysis machine, it's like the size of a washing machine. Okay, so you have to push the blood out into this giant or this big machine through tubes, and then it's connected back into you with clean blood. Now, it works and it keeps people alive, but there's often side effects to it because there's some chemical cleaning of the blood, and nothing is as good as your body at doing those functions. The other problem with hemodialysis is your kidneys can constantly be doing this. So, like we said, they produce a bit of urine every 15 seconds. But with a hemodialysis machine, you can't be hooked up to it permanently. So, basically, what happens is 3 times a week, you go and sit for 3 to 4 hours hooked up to the machine, and they clean all of the blood, and then you don't get to do that again for another couple of days. So typically people are either on Monday, Wednesday, Friday, or a Tuesday, Thursday, Saturday schedule. Excuse me. And that's when I was in the ambulance, I would transfer a lot of dialysis patients who are unable to walk. So we would have them on stretchers and gurneys to take them in and out of dialysis. Okay, so this is what dialysis looks like. Now, if you think about it, you have to take blood out of your body through a machine and then back in. It means 3 times a week they have to open up your blood vessels to take blood in and out. Now, what they do is they create kind of like an easier way to remove blood. And I can show you a couple of examples. If you look at this one first, you probably can see these lumps in their arm. Basically, those are arteries that are being pulled up right onto the surface. Okay, so you have surgery to lift your arteries right next to the skin, and then basically they just break the skin and the tube goes in and blood is taken out and pushed back in. So you have to kind of live your life with these large lumps on your arm. The other option is to have a central line going in. And this is a central line going into the chest, the PICC line. You can also have PICC lines in the arms as well. And they will take the blood. This tube will be permanently attached to the person going into their chest. They don't normally leave these in for like longer periods of time. So most dialysis patients end up with, these are called fistulas or shunts. They end up with these because they're much better for a long term, because you don't really want to have a tube going in and out of your chest, because there's issues with infection and also issues with cleaning. As you can see, that's a shower cover. And there's issues with, if that gets pulled out going into your chest, it's going to lead to some really, really big problems. But dialysis, it's not really the most pleasant experience. You guys probably know some people who are on dialysis at the moment. It's becoming more common. It's basically like a part-time job. You 12 hours a day, you have to be sat in a chair cleaning your blood. Okay. we don't have this as we're not in class. So that's it for today. I will have a notes quiz. Please make sure you're doing that. And I will catch you next time.